It's unbelievable that in such a humble workshop in Pakistan, they can process large ammonia compressor crankshafts. At this rate of development, making lithography machines by hand doesn't seem far off. These discarded ship steel billets bought at $80 per pound are the raw materials for this crankshaft. Processing such heavy ship crankshafts is no easy task for anyone, but it's just routine for the craftsmen in Pakistan. First, they secure the cutting equipment bracket on one end of the crankshaft. Using an acetylene cutting device, they segment the parts needing processing. Due to equipment limitations, each cut section weighs several tons and requires a gantry crane. After hours of cutting, the entire ship crankshaft is finally divided into several pieces. These raw materials are loaded onto tractors and transported to a nearby processing factory. Upon arrival, the craftsmen heat the raw materials to the required forging temperature and repeatedly hammer them under an air hammer to achieve the desired shape and contour. During this process, they must continuously control the air hammer for striking, gradually removing the oxide layer from the steel billet surface. Despite the absence of professional molds, their skilled operation quickly shapes the steel billet to the required form. The steel billet, still at a high temperature, is left to cool naturally. Once cooled, the blanks are transported by donkey cart to a designated processing location. In the workshop, the craftsmen use a hoist to fix the blanks on a lathe. After checking concentricity with a needle gauge, they begin machining the outer edge of the crankshaft. To prevent overcutting, the craftsmen precisely control the feed rate of the cutting tool and measure the cutting values with calipers for subsequent processing steps. After finishing the journal machining at both ends of the crankshaft, they proceed to detailed machining of the middle part. Since the ammonia compressor crankshaft has a 3-cylinder shape, corresponding grooves are machined to the required contour. Ordinary lathes cannot machine the crankshaft's connecting rod journal, so after cutting the grooves, they replace the lathe with an eccentric chuck to process the connecting rod journal. This process requires precise calculation and operation. Each journal takes nearly 2 hours to cut. After several hours of machining, the once rough steel billet gradually reveals the crankshaft's contour, which is only part of the process. Next, the craftsmen suspend the workpiece with a hoist and transfer it to the planer for further processing to remove excess material from the crank. The planer effectively removes burrs and uneven parts from the steel billet surface, making it smoother and more refined. The planer's cutting precision is high, and the finished surface roughness is low, meeting high precision requirements. Once planing is complete, the giant compressor crankshaft is finished. So, what do you think of the compressor crankshaft made by Pakistani craftsmen? If you could rate it out of 10, what score would you give it?